Assalamu alaikum everyone. Dear student, I hope you are fine and doing well. Today our class is about we will introduce another encryption algorithm, another type of encryption algorithm, which are basically the from parabolic key, parabolic public encryption scheme. Goldwasser and Micali are two scientists, or I can say they are two cryptographer, which are quite famous in parabolic encryption algorithm. So I'm not going into the depth of what parabolic key encryption algorithm. I will focus on how gold vessel Micali encryption algorithm work. Then I will introduce some example how three component of public key cryptography with respect to public Goldwasser and Micali encryption algorithm. That is the three component, as you know, and usually three component. Whenever I am talking about, it's obvious it's a three component of public key encryption. That is key generation encryption algorithm and then decryption algorithm. So let us start with but keep one thing in your mind that this gold vessel crypto system is fundamentally based on uh, uh, residue and non-residue quadratic residue and non-quadratic residue, and we will use Euler criteria to study whether some number in modulo class is quadratic residue or not. So let us start with. So GM basically gold vessel. I will short it GM. Crypto system consists of three algorithm, that is parabolic key generation algorithm, and that produce public and private key, and parabolic encryption algorithm, and a deterministic decryption algorithm. So let us start with the scheme. Basically lies on deciding whether given number is a square mod n, means to say quadratic residue or not, given the factorization p and q of n. This can be accomplished by using the following procedure. Like if you have some number xp which is equivalent to x mod p, and xq which is equivalent to again x mod q. If xp power p minus 1 divided by 2 is congruent to 1 mod p, and xq to the power q minus 1 divided by 2 is also congruent to 1 mod p, in that case x is quadratic residue mod n, where n is the fundamentally the product of 2 prime p and q. So key generation, the modulus used in GM encryption is generated in the same manner as in RSA, like N is P into Q. So LS generate to what you call uh, distinct prime number P and Q, such that P and Q is equal to 3 mod 4. It means to say you can take any P and Q. We If you can divide it with 4, you will get 3. Like 3 as usual, like if you can take p and q like 7, and then you can take q as 11. In that case, if you can take p as 7 and q as 11, if you can divide both p and q, what you will get, both remainder of the both p and q, which is p is 7 and q is 11. In that case, you have to select those p and q which are basically these are not congruent sign. Let me p and p is congruent to q, q is congruent to 3 mod 4. It means you can select only those p and q whose remainder is 3 after dividing by it by 4. So let us take LS will compute n is p into q. She then finds some non residue A, such that AP to the power p minus 1 divided by 2 is congruent to minus 1 mod p, and AQ to the power q minus 1 divided by 2 is congruent to minus 1 mod q. So the public key consists of A and N, and the secret key is P and Q, as in RSA. So how we can perform decryption? Suppose Bob wishes to uh, send message to LS. So keep one thing in your mind. Usually we will use LS as a sender and Bob as a receiver, but here in this case, the we take Bob as a sender and LS as a receiver. That is why LS in key generation we use LS, because LS is receiver in that case. And you know, in public key encryption, receiver is fundamentally the owner of the keys. So let us first of all, what Bob wishes to send message like M. If you can, I can highlight this with like this one, like message M to Alice. The boss first encode the M as a string of bits, like n bits M1, M2. For every bit M, Bob generate a random value bi from the group of unit modulo n, or was GCD of bi with n is 1. He output the value that ci is equal to bi square into a mi mod n. And Bob sent the cipher C1, C2. For each bit, you have to apply this encryption algorithm, and you will get corresponding C1, C2, and Cn. And Bob will send this all C's to Alice. Then Alice will receive this one and apply the following procedure for each I using the prime factorization P and Q. LS determine whether the Ci is quadratic residue. If this is quadratic residue, it means using Euler criteria, and suggests that if some Ci's are quadratic residue, so Mi is 0. Otherwise, if it is not quadratic residue, then Mi is 1. LS output the message M like this one. So this is in the form of binary bits. So then LS will convert the binary from convert the message from binary to decimal. So let us take one example. Say we can take P and Q like this. Both P and Q remainder is 3 if you divide this number with 4. So calculate N is P into Q, which is 77, and take any A, 6, like take any random A in this Zn, which is 77. We have taken um, a as 6 and calculate like this is, you know what, we can take A in this, which is non-quadratic residue. It means to say, if you can take 6 to the power 7 minus 1 divided by 2, and which is minus 1, how you can get this one? Like if 6 to the power 6 divided by 2, you will get 6 to the power 3, and 6 to the power 3. What you can say this about 36 into 6? It means 6, and if I can say this one like uh, let me elaborate this one like this one. If you can say uh, 36 into 6, then you can take its mod, like mod of 7. So what you will get ultimately, you will get 6, and this is minus 1 under mod, like let me tell you, 6 to the power 6 divided by 2, so 216. If you can divide it by like 217, So the remainder will be minus 1, and if you can take this like let me elaborate this with how much if you can divide it by more 7, how you can get minus 1, because if you can add you will get 6 after dividing it by you will get 216. If you can divide it by 7, you will get 6. So how many numbers are lesser to achieve 7? It is 1. So you will get in that case minus 1. So 6 to the power 10, which is 6 to the power 5. If you can take 6 to the power 5, like 6, 6 to the power 5, and then take its mod 11, so you will get 10. It means one reduce one is if you can add one uh, and 10, then you will get fully divide this number with 11. So how many you will less, so minus in that case you will get minus 1, because one number is less while dividing it by mod 11. So in that case you will get minus 1. Here you after dividing this result with 7, you will get 6, which is one less than 7. So I put it minus 1. So if you can 6 to the power 5 take its mod, then you will get again 10, which is one less than 11. In that case you will get another time minus 1. In that case the 6 is basically quadratic non-residue. So the public key is 6 and 7, and private keys is 7 and 11. So these 7 and 11 is private key, and these 6 and 77 is public key. So to encrypt the 3-bit message like M1, M2, M3, 101. So choose any BIs. BIs was basically, if you can see, the GCD of BIs with N must be 1. So you can take any BIs from these 77 elements from round 0 to 76. So B1, B2, B3. You can take GCD of 2 with 77 is 1, GCD of 3 with 77 again 1, and GCD of 5 with 77 is again 1. So we have fulfilled the criteria of selecting BIs. So we can calculate C1, C2, C3, 2 to the power 2 into 6 equal to 24 under mod 77, and similarly C2 and C3. Ultimately, we will get 24, 19, and 73. To decrypt the ciphertext, we will compute 24 to the power 7 minus 1 divided by 2, which is minus 1. In that case, 24 is quadratic non-residue. So M will be 1. So 9 to the power 7 minus 1 divided by 2 is 1 mod 7. So in that case 9 is quadratic residue. So in that case M will be 0. So 9 to the power 11 minus 1 divided by again 1, 73 to the power 7 minus 1 divided by 2 equal to minus 1. In that case, as I told you, here, if you can look over here, so determine whether the CI is quadratic residue. If this is quadratic residue, so MI will be 0. If this CI is not quadratic residue, in that case MI will be 1. If you can look over here, so I can calculate the C1, C2, C3. To check whether this some number is quadratic residue or non-residue, I have used Euler criteria over here. 24 to the power 7 minus 1 divided by 2. So here I get minus 1. So in that case, dear student, since 24 is quadratic non-residue, in that case M1 will be 1. In that case, this is equivalent to 1. This calculation is equivalent to 1. So in that case, 9 is quadratic residue. So M2 is 0. 73 is quadratic non-residue. So M3 is 1. So this shows that 24 and 73 are non-quadratic residue and 9 is quadratic residue. Thus the output will be 101, which is our what you call the original plain text, which is to be decrypted. So Venola cryptographic crypto system is another extension of what you call the Goldwasser and Micali crypto system, which you have discussed in our previous slides. So I left this crypto system as an exercise, and you have to understand this encryption algorithm and produce some one or two example for this vanilla crypto system. Thank you, and please stay at home. May Allah bless you all. And if you have any problem regarding this public key crypto system, do ask me, and I will definitely help you out. And will inshallah very soon arrange one another online inshallah online session about the discussion of our course and discussion. If you have any problem, then you can do one arrange one online session. Till then, Allah Hafiz, may Allah bless you all.